What's up, class? Today we are working on probability. Now, remember, if you saw my previous video, probability is between 0 and 1, which when turned into a percent is 0% and 100%. And 0% is absolutely impossible. You can't have anything less than 0%. That is the bottom. And you also 100% is absolutely certain. And so 100%, let me see, 0 and 1, which is 0% and 1%, 100%. And so this is certain and this is impossible. And so you can't have anything more than impossible and you can't have anything more than absolutely certain. And so everything else lies in between here. And it's all situated. And the things you're going to be learning this year in probability is it's all stuff that you already know, things that we've already been teaching you. And so let's go over here to this right here. So probability is a ratio between two things. One, the favorable outcome, which is the outcome that we're looking for. And then the sample space, which means all possible outcomes. All possible outcomes. Okay. So let's take an example. Let's take this die. It has 6 sides. And what if I want to find the P5, which doesn't mean P5 or P times 5. This means when we're talking about probability, it means the probability of getting a 5. Well, if we look at this, what is our sample space? What is the all possible outcomes? I could roll a 1, I could roll a 2, I could roll a 3, I could roll a 4, and I could roll a 5, and I can roll a 6. Okay, so our all possible outcome element count is 6. There are 1, 2, 3, 4, 5, 6 different options. And we want to know what's our favorite, how many favorable outcomes do we have? Well, there is 1. So there is only 1 favorable outcome. So we have a 1 in 6 chance. Okay. And then we can also turn that into a decimal, which would be 0.16 repeating, and I would do that by dividing, and I get 0.16 repeating. And then I could turn that into a percent, which would be 17%. Okay, so let's take this. So what we're really doing is the numerator is our part, and the denominator is our whole. And y'all are familiar with part to whole ratios. And so we're going to take those into the context of these new problems. Okay, so let's say I have a bag of marbles. And in this bag, we have 7 blue marbles, 3 red marbles. That's okay. And then 4 orange marbles and 2 white marbles. Okay. So there's a lot of different marbles in here. And we want to know what is the probability that we'll pull a red, and then we want to express that as a percent. So we can express it as a fraction, then move it to a decimal, and that helps me move it into a percent. So let's go over this. So let's first thing, so it is favorable outcomes. So the favorable outcome out of the total possibility. So the sample space is what it's called. Sample space is all possible outcomes when I just pull 1 marble out of the bag. Well, let's think about our sample space. Our sample space is I can get a blue, or I can get a blue, or a blue, or a blue, or a blue, or a blue. That's 6. And then there's 7 blues. So I can get either one of these blues, blue 1, blue 2, blue 3, blue 4, blue 5, blue 6, and blue 7. Or I can get a red, or the other red, or the other red, or I can get the orange, or the other orange, or the other orange, or the other orange. And you kind of see where I'm going with this, or the other white, or the other white. Okay. And so these are all my possible outcomes. Now let's see how much this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. 16. So there are 16 in our sample space, which is all possible outcomes. And how many, and we're talking about the probability of getting a red, right? So let's see how many favorable outcomes there are. There's 1, 2, 3 favorable outcomes. So we have a 3 in 16 chance of getting a red. So then I could divide this. And so I would do that by taking top in, bottom out. And I would get 0.1875 if I were to work this out, which turned as a percent. So let me do this. 0.0875, and then I move that over twice to turn it into a percent, so it'll be 18.75%. Okay. So the important thing is, yes, you have to master, to be masterful at this type of problem, you have to master what is, how to set this up, but also how to turn this fraction into a decimal and decimal into a percent. You have to have that mastered and understand that. Okay, so let's go over the next one. So this says a spinner is divided equally. So let me draw a spinner. And it's got red, blue, and green. So let me split this into 3 equal parts. We got red, we have blue, and we have green. Okay. What is the probability that the color red will be chosen when spun? Well, how many are in our sample space? How many total possible outcomes are there? There are 3. How many are red? 1. And so this would be 0.33 repeating, and then also 33%. Okay. Now let's look at this. Now let's look at this spinner. So let's consider the spinner below. There's A, B, C, D. There, 2 D's here, and E. Okay, but how many parts are there? There's 1, 2, 3, 4, 5, 6. 6. Each letter has 1 except for the letter D, which has 2. So these are the type of things I need to notice before I start working on problems like this. Okay, so the first question asks, what is the probability of spinning a D on the spinner? Well, we know in our sample space, there is 6 spaces. And how many have our favorable outcome? Well, that's 1 and 2, because our favorable outcome is spinning a D. So that'd be 2 6. I can also reduce this by 2, which would turn into a 1/3 chance, which is easy to find the percent of now if I know my benchmark fractions. So as a decimal, that would be 0.33. I would do that by dividing, or I could just know 0.33 repeating, and then that also turns into 33% if I move the decimal over twice, or really 0.33%, 33.33% repeating. And so that is our percent. So let's look at this next one. Now it says, what is the probability of not spinning a D? Interesting, not spinning a D. Let me go here and erase some stuff. I'm going to erase some stuff here because I don't want us to get confused. Okay. So it says not spinning a D. All right. So let's look. Well, we know 6 are in our sample space, but how many are not D? Well, if 2 6 are D, then how many are not D? There's 2 ways I can do this. I can go over here and count the not Ds. 1, 2, 3, 4. There's 4. Or I can see, well, if 2 are D, then there must be another 4 that are not D, because there's 6 total possible outcomes. 6 total possible outcomes. So if this is D and this is the probability of not D, So 2 are D, then the rest must be not D. And if we think about it, anytime we spin this spinner, we have a probability of either getting a D or not getting a D. And so we have to either get one of the other. And so the probability of getting not D would be 4 out of 6, which is divide these by 2. That'd be 2/3, which is 0.66 repeating, or if I move this over twice, that'd be basically 67%. Okay, well, if I round it to the nearest percent. Okay, and then it says write a numerical expression that relates to the probability of D and its complement. Well, the probability of D, oh, this is called its complement. Complement, it's the opposite of the first one. So this is the probability of D, and its complement is the probability of not D. So complement means that they complete each other. And so this will be 2/6, and this will be 4/6. And if I add those together, this will give me 6/6, which is equal to 1, which is equal to 100% chance that we'll get either one of these. But the main thing that you need to learn today is that a probability like this one, probability of D, and its complement, probability of not D, represent every single possibility that can happen if I spin this spinner. And together, if I were to add these two probabilities together, they're going to equal all of my different possibilities, or 100% chance that either one of these is going to happen. So I hope that made sense. And I will be posting practice problems and going over them with you so you can get a better understanding of those.